Hi everyone, it's Mrs. DeJong here. I'm going to try out this new program. Hopefully it works for you, so just let me know if this isn't working. Today I'm just going to go through the Chapter 3 review questions on page 202. I'm just going to work through them one at a time just to hopefully help you get ready for the test a little better. Just let me know if you still have any questions about these questions afterwards. So we'll start with number 2. We're given the function f of x equals 4 times x minus 2x plus 6. And A asks us to state the direction of opening and the zeros of the function. So our A value is positive 4, which means this parabola opens up. The zeros, we can just read from the equation, are 2 and negative 6. B says determine the coordinates of the vertex. So I can actually find the vertex using my zeros. First I'll find the axis of symmetry. So that's finding the midpoint of the zeros. So 2 plus negative 6 divided by 2 leaves me with negative 4 over 2, which is negative 2. Then I'll take that negative 2 and plug it back into the equation as x, and that will give me the y-coordinate of the vertex. So I have 4 times negative 2 minus 2 times negative 2 plus 6 leaves me with 4 times negative 4 times positive 4 leaves me with negative 16 times 4, which is negative 64. So therefore my vertex is negative 2 comma negative 64. C says state the domain and range. So I know this is a parabola that opens up and its vertex is negative 2, negative 64. So my x values can be anything. And my y values for my range are going to be anything above the negative 64 from the vertex. So y is a member of the reals such that y is greater than or equal to negative 64. And that's because the parabola opens up. Letter D asks us to graph the function, so I'm just going to get some graph paper here for a second. So using what I know the zeros and the vertex and the direction of opening. So using those three things, I can graph it. So I need to go down to at least negative 64, so I'm just going to go down by tens here. And then I'll just go up by ones on the x-axis. All right, so my zeros were 2 and negative 6. And my vertex was negative 2, negative 64. And I know it opens up, so I'm just going to connect those lines, those dots. And that is my graph. So I have this is f of x equals 4, x minus 2, x plus 6 is that line. And that's number 2. All right, next is number 5. Number 5 says the height in meters of the trajectory of a football is given by h of t equals 2 plus 28t minus 4.9 t squared, where t is the time in flight in seconds. Determine the maximum height of the football and the time when that height is reached. So I'm going to start by writing down the equation. H of t equals 2 plus 28t minus 4.9 t squared. The first thing I'm going to do is I'm going to rewrite this equation in the correct order for standard form. So that I'll start with the t squared and then the t and then the constant. So negative 4.9 t squared plus 28t plus 2. Now I need to find the maximum height, so that would be the vertex. So in order to find the vertex, I'm going to complete the square. So I'm going to start by taking out my a value. 28 divided by negative 4.9 is negative 5.71. And then I'll leave that 2 outside of the bracket. Then in order to complete the square, I'll take half of negative 5.71 and I'll square it, which leaves me with 8.163. So then I'm going to add and subtract 8.163 inside the bracket. Now I want to get this second 8.163 out with the bracket, so in order to do that I have to multiply it by negative 4.9. So now I'm left with negative 4.9 t squared minus 5.71 t plus 8.163 bracket plus 40 plus 2. Now I need to factor my bracket, so my perfect square that I've created will be half of 5.71, which was negative 2.86, squared plus 42. So my vertex is 2.86, 42. So the maximum height is 42 meters, and that's reached at 2.86 seconds. All right, number 7. Is the inverse of a quadratic function also a function? Give a reason for your answer. So if I have a quadratic and I'm going to graph the inverse, it will look something like that. So now this will not pass the vertical line test. So that is not a function. The inverse is not a function because it won't pass the vertical line test. All right, number 8. Given this graph, sketch the graph of the inverse and then state the domain and range, and then C says, is the inverse relation a function, why or why not? So the first thing I'm going to do is graph this, the inverse of this. So I'm just going to switch to graph paper here. So in order to switch graph the inverse, I'm going to switch the x and y coordinates. So I'm just going to draw a little graph. So I have the coordinate 0, negative 4. So now I'm going to do negative 4, 0. I have 4, negative 4. So now I have negative 4, 4. I have 1, 2. So now I have 2, 1. I have 3, 2. So now I have 2, 3. And then I have 2, 4, so now I have 4, 2. And then I'll just connect these dots. And that's the inverse. Now, that was A. B, the domain and range. So the domain, what x values are possible for this? All the x values on this side of the vertex. So x is a member of the reals such that x is less than or equal to 4. And then the range can be anything because all of our all of our y values are possible. And then C asks us if this is a function. And check with the vertical line test, no, not a function. All right, number 9. Now we're on to lesson 3.4. So express each number as a mixed radical in simplest form. A is the square root of 98. So remember, with radicals, you want to break it down so that it includes at least one perfect square. So I can break this one down into root 2 times root 49. The square root of 49 is 7. So now I'm left with 7 root 2. B is negative 5 root 32. Root 32 can be broken down into root 16 root 2. The square root of 16 is 4. So negative 5 times 4 is negative 20. So I'm left with negative 20 root 2. C is 4 root 12 minus 3 root 48. The square root of 12 can be broken down into the square root of 4 times the square root of 3. The square root of 48 can be broken down into the square root of 4 times the square root of 12. So now I'm left with 4. The square root of 4 is 2 times root 3 minus 3. The square root of 4 is 2 again. And then I'm going to break down root 12 again into root 4 root 3. Now I'm left with 8 root 3 minus 3 times 2 is 6. And then root 4 is 2 times root 3 equals 8 root 3 minus 12 root 3. Now, since these are both multiplied by root 3, they're like radicals. So I can do 8 minus 12 is negative 4 root 3, and that's my final answer. D. I have 3 minus 2 root 7 squared. So as soon as I see that squared, I'm going to expand. So now I'm going to multiply each term in the first bracket by each term in the second bracket. So 3 times 3 is 9. 3 times 2 root 7. And then 2 root 7 times 3. And then 2 root 7 times 2 root 7. Three times 2 root 7 is 6 root 7 minus another 6 root 7 plus 4 times 7, because I do 2 times 2 is 4, and then root 7 times root 7 is root 49, which is equal to 7. Now I have 9, and then I have negative 6 root 7 and another negative 6 root 7, which is negative 12 root 7, plus 4 root 7. Sorry, okay, back up. That's not root 7, that's just regular 7. So that would be 28. So now I have 9 plus 28 minus 12 root 7 equals 9 plus 28 is 37. 37 minus 12 root 7. And that's as far as I can simplify that. All right, number 12. Determine the x-intercepts of the quadratic function f of x equals 2x squared plus x minus 15. So f of x equals 2x squared plus x minus 15. So to find the x-intercepts, I just need the zeros. The x-intercepts are the zeros, so I'm just going to factor if possible. So let's check if this is possible. So 2 times negative 15 equals negative 30. So I need two numbers that multiply to negative 30 and add to 1. So that would be 6 times negative 5, because 6 plus negative 5 equals 1. So now I'm left with 2x squared plus 6x minus 5x minus 15. I'm going to group them and then factor. So 2x I can take out of this group, x plus 3 minus 5x plus 3 equals 2x minus 5 times x plus 3. So now that I have it factored, I set each section equal to 0 and solve for x. And those are my zeros. So now I have 2x equals 5, add 5 to both sides, divide both sides by 2, x equals 5 over 2, or 2.5. On this side, just subtract 3 from both sides, x equals negative 3. So my x-intercepts are 2.5 and negative 3. Number 14. A rectangular field with an area of 8,000 meters squared is enclosed by 400 meters of fencing. Determine the dimensions of the field to the nearest tenth of a meter. So I have a rectangular field. I know the area is 8,000 meters squared. And that is 400 meters of fencing. So that would be the perimeter, is 400 meters. I already know some formulas for area and perimeter, so I'm going to write those down. So area equals length times width, and perimeter is 2 length plus 2 width. Now I'm going to replace A and P with those numbers in the box up here. So I have 8,000 equals length times width, and 400 equals 2 length plus 2 width. Now I'm going to number these as 1 and 2. I'm going to rearrange the second equation to isolate L. So now I have 400. I'm going to take away 2w from both sides, equals 2L, then divide both sides by 2. So I'll be left with 200 minus w equals L. I'm going to call that number 3. Now I'm going to take number 3 and put it back into number 1. Sorry, this should be number 1, not this. Area equals length times width. So I'm going to take number 3 and put it back into number 1. So now I have 8,000 equals L, which is 200 minus W, times width. So now I have 8,000 equals, I'll expand this out, 200W minus W squared. And then I'm going to move that 8,000 over to the other side so that the whole thing equals 0. So now I have 0 equals 200W minus W squared minus 8,000. And then I'm just going to rewrite the equation so that's in standard form. So rearrange it. So negative W squared plus 200W minus 8,000. Now I'm going to factor this to find the possible values for W. So just by looking at it, it doesn't look easy to factor, so I'm going to use the quadratic formula. So W equals negative B, so negative 200 plus or minus the square root of 200 squared minus 4 times negative 1 times 8,000. It's not going to fit on my screen. Divided by 2 times negative 1 equals, it ends up equaling 55.28 and 144.72. Now I'm going to call those number 4 and 5. And then I'm going to put number 4, so this is the width. Now I need to find the possible length. So an easy equation there is 3, so I'm going to put 4 into 3. So length equals 200 minus width, which is 55.28. So that would leave me with 144.72. And then I'm going to put 5 into 3 as well. And I'm left with length equals 200 minus 144.72, which leaves me with 55.28. So either way, my only two options are 144.72 and 55.28. So therefore, the dimensions of the field, length times width, whichever way you look at it, is 144.72 by 55.28 meters. All right, number 15. The height of a projectile in meters can be modeled by the equation h of t equals 14t minus 5t squared, where t is the time in seconds after the projectile is released. Can the projectile ever reach a height of 9 meters? Explain. All right, so I have this equation, h of t equals 14t minus 5t squared. And our question is, can it reach 9 meters? So I'm just going to put 9 in for height. And then I'm going to rearrange this equation so it's in standard form. So subtract 9 from both sides. 0 equals 14t minus 5t squared minus 9. And then rearrange it so the t squared comes first. So negative 5t squared plus 14t minus 9. Now, if this is possible, the discriminant will either be 0 or greater than 0. If the discriminant is negative, it's not possible. So we're going to take the discriminant from the quadratic formula, which is b squared minus 4ac, and we're going to plug the a, b, and c values into the discriminant from this equation and check if the result is equal to or greater than 0. So b is 14, so 14 squared minus 4 times a, which is negative 5, times c, which is negative 9. So 14 squared is 196, minus 4 times 5, negative 5 times negative 9 is 180, and the result is 16. That's a positive number, so therefore, yes, the projectile can reach this height. It can reach 9 meters. All right, number 16. Determine the values of k for which the function f of x equals 4x squared minus 3x plus 2kx plus 1 has two zeros. Check these values in the original equation. So we're going to use the discriminant again. In order for this function to have two zeros, the discriminant has to be greater than 0. So f of x equals 4x squared minus 3x plus 2kx plus 1, and b squared minus 4ac has to be greater than 0 because it has to be positive in order for it to have two zeros. So my a value is 4, my b value is negative 3 plus 2k, and my c value is 1. So I have negative 3 plus 2k squared, that's b, minus 4 times a, which is 4, times c, which is 1, is greater than 0. So I'm going to expand this bracket out. So negative 3 plus 2k times negative 3 plus 2k, and then negative 4 times 1 is negative 16. If I expand this out, I'll be left with, 9 minus 6k minus 6k plus 4k squared, and then minus 16 on the end. I'm just going to simplify that and rearrange it right away into standard form. So 4k squared minus 12k, and then 9 minus 16 is negative 7 is greater than 0. And I'm going to factor this to find the possible k values. So 4 times negative 7 is negative 28. Two numbers that multiply to negative 28 and add to negative 12 would be negative 14 times positive 2. And then negative 14 plus 2 equals negative 12. So 4k squared plus 2k minus 14k minus 7 is greater than 0. Group and factor, so take out a 2k out of the first section, k plus 1 minus 7. Sorry, should be 2. And it should also be 2k plus 1 is greater than 0. So 2k minus 7 and 2k plus 1 are greater than 0. So therefore, now solve for k. So k is greater than 7 over 2, and k is less than negative 1/2. So for those values, if k is greater than 3.5 or less than 1.5, this function will have 2 zeros. All right, number 20. Says, an engineer is designing a parabolic arch. The arch must be 15 meters high and 6 meters wide at a height of 8 meters. Determine a quadratic function that satisfies these conditions. What is the width of the arch at its base? So I'm just going to start with a little sketch here. So I have an arch, has to be 15 meters high, and it's 6 meters wide at a height of 8. So that if I made this line down the center, the y-axis, and this the x-axis, that would put my vertex, my maximum height, at 0, 15. You could have done this a different way, and you'd still have a correct equation. There can be multiple equations for this. One point on this graph that I know is that if this whole thing is 6 here, then this small one would be 3. So that would make this point 3, 8. So a point that I know on this line would be 3, 8. So using those two things, I can find an equation for this. So I'm going to use vertex form since I know the vertex. So vertex form is y equals a x minus h squared plus k. Plug in the vertex for h and k. So y equals a x minus 0 squared plus 15. And then now to solve for a, I'm going to plug in this 0.38. So 8 equals a 3 minus 0 squared plus 15. 8 equals a 3 minus 0 is 3, squared is 9, plus 15. Now, I need to get this a by itself, so I'm going to subtract 15 from both sides. 8 minus 15 is negative 7. Negative 17 equals 9a. Divide both sides by 9. A equals negative 7 over 9. So therefore, my equation would be y equals negative 7 over 9 times x minus 0, which is really just x squared, plus 15. Okay, I'll continue on the next video.